Why giant ship chains don't break. The process. Imagine a container ship weighing 200,000 tons. It's being battered by a violent storm in the middle of the ocean. The engines are off. The only thing stopping this billion-dollar vessel from crashing into the rocks is a single chain. If one link fails, the ship is lost. So, how do engineers build a chain strong enough to hold a floating city? It involves temperatures hot enough to melt rock, millions of pounds of pressure, and a manufacturing process that looks like it belongs in a sci-fi movie. Welcome to the world of extreme manufacturing. It starts here. These aren't just ordinary steel rods. This is special high-grade alloy steel, designed to be both incredibly hard and slightly flexible. If the steel is too brittle, it snaps under shock. If it's too soft, it stretches. The rods arrive in long bundles, some up to 6 meters long and weighing as much as a small car. Before they can be shaped, they need to be cut. Giant automated saws slice the steel into specific lengths, called slugs. But you can't bend cold steel this thick. You need heat, a lot of heat. The steel slugs enter an induction furnace. In a matter of minutes, they are heated to over 900 degrees Celsius. They emerge glowing a bright, angry orange. Now the race is on. The steel must be shaped before it cools down. Watch this. A robotic arm, or sometimes a skilled operator with giant tongs, grabs the burning metal. It feeds it into the bending machine. This is where physics gets bent. The machine grabs the straight bar and wraps it around a central mandrel. It looks effortless, like bending a piece of licorice, but the forces here are astronomical. It loops through the previous link in the chain. This is a continuous process. As one link is formed, it locks the chain together. But if you look closely, there is still a gap. The loop isn't closed yet, it's just a bent piece of metal. To make it a circle, we need fire. This is the most critical step, flash butt welding. The machine clamps onto both sides of the open link and pushes them together. Then it blasts a massive electrical current through the metal. The resistance is so high that the steel ends literally liquefy instantly. Sound effect? Bzz, bzz, crackle. See those sparks? That's impurities being blasted out of the metal. The machine pushes the two molten ends together with incredible force, fusing them into a single, solid piece of steel. The weld is actually stronger than the original bar itself. You might notice these chains look different from the ones on your bicycle. They have a bar across the middle. This is called a stud. While the link is still hot, a machine jams the stud into the center. Why? 2 reasons. First, it prevents the chain from tangling up like headphones in your pocket. Second, it stops the link from collapsing inward under heavy tension. But we aren't done. The welding process made the metal stressed. To fix this, the entire chain goes back into the oven for heat treatment. It's quenched in water and tempered. This realigns the crystal structure of the steel, making it tough enough to survive 20 years in salt water. Finally, there is no room for error. Every single chain must be torture tested. The finished chain is hooked up to a hydraulic tester. The machine pulls it with hundreds of tons of force, far more than it will ever experience at sea. They measure how much it stretches. If a link cracks, the whole section is scrapped. Only after passing this brutal exam is the chain painted with black tar to prevent rust and shipped to the shipyards. So the next time you see a massive ship docked peacefully in the harbor, remember the monster chains hiding underwater, holding it all in place. If you enjoyed this look into extreme engineering, hit that like button and subscribe to Forgotten Tech Files. What manufacturing process should we uncover next? Let me know in the comments.